Welcome to ADAS Garage, where we dive under the hood of advanced driver assistance systems. From calibrations to cutting-edge tech, we explore the innovations shaping the future of vehicle safety and automation. Buckle up, because the road ahead is smarter than ever. This podcast is brought to you by Centric, providing OEM-level ADAS calibrations designed to support your business, powered by Burke Porter.
Have you ever stopped to think about the incredible technology packed into modern cars that helps prevent crashes? We're talking about advanced driver assistance systems, or AD. They're designed to be your car's second set of eyes, a true guardian angel on the road. But what if those eyes aren't seeing clearly? Today, we're taking a deep dive into something absolutely critical for these systems to work. ADAS calibration. It's not just some technical detail, believe me. It's the difference between a system that saves your life and one that simply fails, often silently. Our mission here is to unpack why precise calibration is so vital for safety, functionality, and regulatory compliance. And we're going to dive deep into some fascinating real-world test data to prove it.
Indeed. And we're drawing our insights from a comprehensive white paper titled ADAS Collision Prevention White Paper v3-1.pdf. This document really lays bare the states, especially with the upcoming enforcement of things like FMVSS 127.
Yes, the federal mandate for automatic emergency braking systems.
Exactly. It mandates minimum performance standards. So the implication here is pretty clear. The accuracy of these systems is paramount. And look, improper calibration exposes everyone, from the service providers to you, the vehicle owner, to significant risks, both on the road and, frankly, legally.
Okay, let's unpack this a bit. A slight misalignment in a sensor, maybe just a degree off, can have catastrophic effects down the road, literally. So how do we actually ensure these complex systems are working perfectly? That's what we're here to discover. But before we get to the really granular data, let's quickly set the stage on why ADAS is such a game changer when it does work. I mean, we're talking about systems like forward collision warning, FCW, and automatic emergency braking, AEB. These have been shown to reduce rear-end collisions by about 50%.
That's huge.
It is huge. And then you have lane departure warning, LDW, cutting single vehicle and head-on crashes by 11%, and pedestrian AEB, PAED, that's shown to cut pedestrian collisions by 27%. These aren't small numbers.
No, they're potentially saving thousands of lives every year. But what's fascinating, and maybe a little scary, is that all these benefits hinge entirely on the accuracy of the sensors. ADS sensors, cameras, radars, you name it, they are incredibly finely tuned instruments. The white paper highlights this. If a sensor's aim is off by just 1 degree or even a few millimeters, well, that error gets magnified over distance.
Right. So like at 50 feet down the road.
At 50 feet, it could mean the sensor is looking several feet off target. Feet.
Wow. And that raises the big question, what happens when that precision is compromised? Especially if you don't know it.
Exactly. And here's where it gets really interesting. Often, the car won't even tell you there's a problem.
Seriously. No warning light.
Most vehicles won't activate a warning light for these subtle but critical misalignments. You're left completely unaware.
That's what you call a silent failure.
That's precisely it, a silent failure. And real-world data backs this up strongly. There was an IIHS survey mentioned in the paper. It found about half of car owners reported problems with their AD after repairs.
Half. That's a lot.
Yes, especially when a windshield was replaced or after some kind of crash damage. It suggests proper calibration is often overlooked, creating this widespread hidden problem.
Okay, so this study we're looking at today actually tried to quantify what those problems look like under controlled conditions.
Exactly. It moves beyond anecdotes and measures the actual performance impact.
All right, let's get into it. The core deep dive. What did the testing involve?
So the white paper details a very structured analysis. It was conducted at the Transportation Research Center, TRC, a top-tier independent facility. Burke Porter commissioned the study.
Okay.
They took a 2024 Nissan Altima, a pretty standard modern vehicle, and put it through a rigorous set of tests under different calibration scenarios. The goal was to quantify the impact on key AAS functions.
Different scenarios, like what?
Well, the methodology is key here. They evaluated 4 distinct calibration states to mimic what happens out there in the real world. First, a factory baseline. This was an OEM-calibrated car, but it had about 12,900 miles on it, so, representing a typical car in use.
Okay, makes sense. Some normal wear and tear.
Precisely. Second, no calibration. This simulates what happens if sensors get disturbed maybe during a windshield replacement or bumper repair, and then no recalibration is done at all.
Just left misaligned.
Exactly. Third, poor calibration. This one is interesting. It was done deliberately under bad conditions. Think sun glare hitting the sensor or calibrating on a sloped surface, clearly ignoring OEM procedures.
So highlighting why the environment and process matter.
Absolutely. It shows what happens when corners are cut. And finally, fourth, good calibration. This was an OEM-compliant calibration, but performed at a Burke Porter facility using their advanced systems, focusing on high automation and high precision in a controlled environment.
So comparing baseline, nothing, bad, and then a really high-quality, precise calibration.
That's the setup. High automation and high precision were key differentiators for that good calibration scenario.
And the tests themselves, what systems did they look at?
They covered a whole spectrum of crucial safety functions. Lane departure warning, LDW. Forward collision warning, FCW. Crash imminent braking, CIB, that's the automatic braking part.
Right.
Adaptive cruise control, ACC. And pedestrian automatic emergency braking, PAEB. And they didn't mess around with the measurements.
How so?
They used incredibly precise tools, an OXTS RT3003 GPSIMU for tracking vehicle motion down to the centimeter, AB dynamics, robotic targets for consistent obstacle simulation, even a ferroquantum E arm.
A ferro arm? For what?
To verify the actual sensor alignment down to the millimeter level before each test run. We're talking serious precision here.
Okay, so the methodology is robust. Let's get to the results. What did they find, scenario by scenario?
All right. Let's start with lane departure warning, LDW, the system that warns you if you drift. In the no calibration scenario, complete failure. 0.000 inches of alert distance.
0. So no warning. Ever.
None. Might as well have been switched off. Then, poor calibration. This introduced asymmetry. Late alerts, only 3.60 inches of warning distance because of a yaw misalignment. Basically, the sensor was looking sideways.
Useless.
Pretty much. But crucially, the good calibration, the high precision one, restored performance right back to actually slightly better than factory level. Consistent symmetric alerts at 7.53 inches. Much safer.
That difference in inches could be everything in avoiding a sideswipe.
Absolutely. Now, forward collision warning, FCW, and crash imminent braking, CIB, and this is where it gets incredibly stark. The no calibration vehicle, it didn't engage the brakes at all, resulting in a full impact with the target vehicle in 100% of the tests. Every single time, it crashed.
Wow, that's chilling.
It is. In stark contrast, the good calibration scenario delivered the most consistent timely alerts and achieved a 100% avoidance rate. And importantly, it had the longest ever starting margin, 46.76 feet minimum distance to the target. A huge safety buffer.
Okay, so good calibration didn't just avoid the crash, it did so with much more room to spare. How did the others compare?
Interestingly, both the baseline, 40.9 feet margin, and the poor calibration, 40.91 feet margin, also achieved 100% avoidance in these specific test conditions. But, and this is critical, the good calibration was clearly more aggressive and reliable in its braking action. That extra margin, that consistency, that's what the high precision delivered.
More reliable, more buffer. Got it. What about pedestrians?
AEB. Yes, pedestrian automatic emergency braking. PAEB. And this is so relevant given pedestrian fatalities have surged, up over 77% since 2010 in the U.S.
A terrible statistic. How did the systems perform?
No calibration. Total failure. Didn't detect the pedestrian target at all.
Again, completely blind.
Completely. The baseline vehicle showed inconsistent performance. Sometimes it braked well, other times, while impacts were observed. The minimum distance recorded was just 1.51 feet.
That's way too close, and near hit at best.
Far too close. But the good calibration system, it delivered the earliest alerts and achieved 100% consistent avoidance. And the stopping margin, 4.19 feet from the pedestrian dummy.
So over 4 feet, compared to 1.5 for the baseline.
It more than doubled the stopping margin compared to the baseline vehicle. That's a massive, potentially life-saving improvement directly linked to the quality of the calibration.
Incredible. So good calibration isn't just about pass-fail, avoiding a crash. It's about how well you avoid it. The safety margin, the reaction time, the consistency.
Precisely. And the study also quantified that consistency, looking at variability and predictability. For PAEB alert timing, for instance, they calculated the coefficient of variation, basically, a measure of how scattered the results are. Lower is better, meaning more predictable.
Okay.
The good calibration had the lowest C of V at just 4.74%. Compare that to the baseline at a much higher 13.72%.
13%. That's quite variable.
And poor calibration at 6.59%. So good calibration doesn't just improve average performance, it makes the system significantly more reliable and predictable, less chance of nasty surprises.
That predictability has to come from the precision of the calibration process itself, right? Fewer variables in the setup.
Exactly right. High automation, high precision reduces that variability.
So just to summarize those improvements over the baseline again.
A good calibration gave a 177% improvement in pedestrian stopping distance, a huge leap, and a 2.2% improvement in the FCW alert time, giving the drivers slightly more warning.
It truly restored and, in some cases, clearly enhanced the system's protective capabilities.
The conclusion from this whole section of the white paper is, frankly, unequivocal. I'll quote it. Proper calibration is not optional. It is the difference between a system that saves lives and one that fails silently.
Wow. Hard to argue with that based on this data.
The research really nails it down. The method, the precision, it directly impacts whether the system works when needed.
So, okay, we've seen the hard data. Let's talk broader implications. The so what. What does this mean for, everyone involved? Owners, repair shops?
Well, connecting this to the bigger picture, these findings slam right into regulatory compliance, like that FMVSS 127 mandate we mentioned. Poorly done calibrations, like the poor or no calibration scenarios here, would almost certainly lead to systems failing these new federal safety tests.
So compliance is a major factor.
Huge. But it goes deeper. Here's something else the white paper points out that's pretty concerning. Despite how advanced ADAS tech is in the car, some of the service procedures specified by OEMs for calibration are described as extremely outdated.
Outdated how?
Think repair shops still being told to use plumb bobs and tape measures.
You're kidding. For aligning sensors that need millimeter accuracy.
Exactly. Plumb bobs. These manual, imprecise methods naturally introduce high variance and a lack of repeatability. It makes achieving that vital, consistent calibration extremely difficult.
That really highlights the gap, doesn't it, between the tech in the car and the tools sometimes used to fix it.
It does, and it underscores why solutions using high automation and high precision, like the methods used for the good calibration tests, are becoming so critical. They bridge that gap, ensuring consistent, reliable results.
And the cost of not doing it right or skipping it altogether?
It's definitely not just about saving a few $100s on a repair bill. And by the way, most insurance companies are covering proper calibration now because they see the safety data, they understand the risk.
Right, they get it.
The real cost is safety, plain and simple. And then there are the very real legal liabilities for repair shops. Imagine sending a car back out with safety systems, aren't working correctly because they weren't calibrated.
It's truly an accident waiting to happen. Potentially devastating consequences, legally and, more importantly, humanly.
Precise.
Okay. This deep dive has really laid bare the tangible, life-saving impact of proper ADAS calibration. It seems absolutely clear. A good, precise calibration restores and significantly enhances how these systems perform. A poor one introduces dangerous unpredictability. And no calibration at all. That results in a silent, potentially deadly failure.
Absolutely. The evidence from this study across all the scenarios, LDW, CAB, PAEB, it undeniably reinforces that calibration isn't some optional extra step. It's fundamental. It's an essential part of maintaining vehicle safety in the modern age. It truly is the difference between a car that protects you and one that just gives you a false sense of security.
So thinking about this, what does it all mean for you listening? Our vehicles are increasingly relying on these electronic eyes and ears, these guardian angels. What responsibility do we have as drivers? And what responsibility do those who service our vehicles have to make absolutely sure these systems are always seen clearly? Maybe it really is time for ADAS calibration to be as routine and as diligently performed with precision tools as something like an oil change. That's definitely a powerful thought to chew on. Thanks for joining us on this deep dive into ADAS calibration.